In the previous video, we talked about the action potential in electrical terms. We talked about the resting membrane potential being at negative 70 millivolts. We talked about the threshold being at negative 60. We talked about uh, becoming more negative. It's called hyperpolarization. Becoming less negative. It's called depolarization. We talked about how depolarization is um, aka excitation. We talked about how hyperpolarization is aka inhibition. Great. But what's actually happening underneath the surface is chemistry. Now, it's not complicated, it's actually very straightforward. Uh, and we'll go through it nice and slow, and you'll be fine. But before we get to that, we need to talk about a little bit of physics. Just a little bit. There are two forces of nature that we need to discuss. Now, both of these have to do with balance. See, nature wants balance, seeks balance. When things are out of balance, nature tends to rebalance them. Two forces that nature has to rebalance situations: the force of diffusion and the electrostatic pressure. These are very important to understand. Okay, diffusion, very straightforward. If I have a cup of coffee, you know that if I wanted to put some milk in my cup of coffee, I couldn't just pour it in this half of the cup. Because when I dump my milk in there, there are going to be a lot of milk particles here, and no milk particles anywhere else. Now, even without the force of the milk falling in, diffusion would mix this solution such that it would take particles from area of high concentration to areas of lower concentration. Okay? So diffusion is simply the idea that when you have particles in some medium and you have an area with high concentration of that particle next to areas with lower concentration, diffusion will move these particles away. Okay, so that you get a nice balanced distribution. So diffusion is interested in concentration. Here is a high concentration of particles, here is low concentration of particles. Diffusion's role is to homogenize so that the concentration is equally distributed. Pretty straightforward to understand. I think equally straightforward to understand is the electrostatic pressure. This is magnets. Opposite charges attract. They're drawn towards each other. Similar charges repel. Wow, wow. Similar here. Similar charges repel. Now, if we have an area like our axon where it's negatively charged inside, and you are so if you're negatively charged inside, you're positively charged outside, right? You're positively charged outside. So if you're a negatively charged particle, where are you going to want to be? Outside the cell or inside the cell? Of course, outside. Outside, because opposite charges. And if you're a positively charged ion, if you're a positively charged particle, where do you want to be? You want to go inside. Okay? And if you happen to be positively charged inside the cell wants you in there, right? Well, electrostatic pressure, to be more precise, wants you in there because you're an opposite charge and we want you there. Great. Pretty straightforward. Now, one thing to keep in mind is that these two forces are completely independent. Let's put a line through them. They don't affect one another. What they have in common is that they're trying to reach balance. Diffusion, concentration balance. Electrostatic pressure, charge balance. Keep these forces in mind because they are absolutely critical to our understanding of what's happening here. We'll start with this on the next video.